we're short on time and we already are a little bit delayed, so we're going to pause all questions till the end, and then at that time we can field anything that might come up. So about Connecticut, we've actually been in the GPU game for quite a while. So our two founders, Amit Vij and Nima Negaban, started working with the GPU back in 2009 as part of a project they were working on with the ENSCOM division of the US Army. The use case they were tackling was a lot more than a use case. It was actually the detection and aversion of national security threats by tracking digital footprints. So, you know, all kinds of different streams of data, being able to identify anomalies in real time and head off the next potential disaster. These folks worked with a lot of technology that people have heard of today in an attempt to solve this use case. And, you know, this involves things like Apache Accumulo and a lot of the open source technology. They tried solving some of these national security threat concerns with CPU-bound in-memory technology. And what they found was, due to one reason or another, there really wasn't enough horsepower in order to solve these problems. They lacked the ability to take large-scale streaming complex data sets, layer them on top of each other, and come up with instantaneous results. So they had to build from the ground up something new, and then that's when they had the idea, you know, if we could provide this brute force analysis by utilizing GPUs, we might really be able to create a system that would be, you know, good enough to handle these national security threats that they're taking on. So, you know, dating all the way back to 2009, we started looking at this technology. And what this means for us is we have a lot of experience, you know, over the past 9 years in utilizing the GPU to solve some of these problems. So flash forward a couple years, we began rolling out this systems to the ENSCOM division of the US Army. A little bit later, we started working with the US Postal Service. We actually won numerous awards from the IDC for innovation, and we productionalized the US Postal Service's use case. This is actually something that's readily available online in public, so we can all drill into that after this presentation. Flash forward to about a year and a half ago, we decided to roll this out of the federal government and began offering it to the enterprise. And the adoption has been pretty high. So, you know, when we look at our customer base, Fortune 1, Fortune 10, Fortune 100 organizations are signing up for this because it's breaking them free from the constraints of CPU-bound architectures. So in terms of how the GPU is being utilized across that customer base, there's a whole list of things that it's really not necessary for, right? You know, to a certain extent, when you're talking about the horsepower that comes with utilizing a GPU for analytics, you know, you might be going after a mosquito with a bazooka. So, you know, all the way on the left, we're talking about simple reporting and just asking basic questions of what happened with our business yesterday. This is stuff that was, you know, easily being solved in the late 90s, early 2000s with the rise of a lot of EDW architecture. But as more modern data sets came online and everything started being, you know, basically a field-deployed sensor-enabled piece of equipment sending a signal back to a mothership, the data volumes got bigger, the complexity of the data got bigger, and the questions that organizations need to ask of that data got bigger. You know, this involved, you know, not only servicing their customers depending on their respective vertical, but also competitive advantage over a lot of other organizations that might be able to harness this technology better. So as we start moving down the line, you know, real-time analytics about 7, 8 years ago started being all the rage with a lot of in-memory bound systems. But the reality was high cardinality data sets and a lot of large in-motion data sets choked these systems out and didn't really provide accessibility to real-time results that customers demanded. Flash forward to today, the problems are even a little bit different. Can you have one machine teaching another machine what to do in order to start predicting not only what's going to happen tomorrow, but 3 months from now? Can you make predictive analysis against a lot of field-deployed equipment so you could head off operational expense from pulling assets out of the field? And this is really where you start getting into the machine learning and the deep learning and a lot of things that the Connecticut relationship with NVIDIA brings online. So why the GPU? This is probably extremely redundant for a lot of the people in this room, but it really comes down to being able to do a lot more with a lot less. You look at the 4,000 core count of a GPU versus the 16 to 32 core count of a CPU, and obviously you're able to do a lot more on a lot smaller footprint, and you're also able to take jobs that are done in a highly repeatable fashion, layer them on top of each other, and just do brute force analysis on data sets that a simple CPU can't do. So, you know, one of our top SEs describes this as the difference of driving on a highway versus driving on the Autobahn. You know, you're driving down the highway, it's a great way to get from point A to point B, but you get too many cars on that highway and all of a sudden you have traffic, you have accidents, and you're in a slowdown. So too many cars, too much information causes a bottleneck. Then you think about something like the Autobahn, where you have tons of lanes and you have a whole bunch of cars that aren't restricted by speed limits. They're certainly able to get from point A to point B a lot faster. That's not to say that, you know, the Autobahn's a better mode of transportation than a highway in any stretch of the means, but for some trips, I'm sure anybody that's in the Bay Area or anywhere else in LA or DC, you know, knows it's much better. You'd rather be on the Autobahn. You can flip to the next slide. So the areas in which that we are seeing a tremendous amount of traction for streaming analytics with the GPU really focus on 3 core competencies, and these really represent 3 horizontal use cases that waterfall into vertical use cases, but the tenets of the problem are really the same across most of the industries that we've worked with. This includes the federal government, it includes retail, it includes financial services, CPG, oil and gas utilities. All of their problems kind of stem from the basis of these different areas of competency. So the first is advanced location-based analytics, right? So for just about any different vertical, the ability to take 1 billion different endpoints, plot them out on a heat map, and utilize a bounding box query to drill in not only where something is happening, but what and why that's happening in real time is it's an incredible feature that a lot of organizations can utilize across multiple industries. So being able to do this in real time with very large, complex streaming data sets is an important asset to a lot of customers. The second we refer to as advanced OLAP, and this is that sensor-enabled field-deployed equipment sending a signal back to a central data repository, and this really makes up the foundation of a lot of IoT-based use cases. So as organizations really grapple with getting their arms around true IoT, the type of functionality provided by GPU-accelerated analytics on streaming data sets becomes critical for them. And the third is what we call advanced in-database analysis. And this is basically GPU acceleration of connectivity back to popular machine learning, deep learning, and artificial intelligence libraries that a lot of organizations are utilizing for machine learning and deep learning use cases, et cetera. So, you know, when we look at the communication between that library and the database, GPU accelerating that and also creating the ability to simply surf your data model across the different libraries cuts off a lot of the time to value that customers experience when attempting to go down these paths. So, you know, this advanced in-database analysis is really driving adoption of GPUs in the data center. A couple of our largest customers are doing some really cool things like mapping the human genome to various ingredients and drugs to cut down R&D time and also push them to market faster to help deliver cures to patients. So we're seeing a lot of really creative adoption of the in-database analysis aspect of things. Next. So from here, Woody's going to jump into a little bit of the architecture in terms of how we're utilizing GPUs for these streaming data sets, and then we're going to jump into a demo and we'll be able to take some questions at the end.
All right. So now I get to be more than the prettier version of Vanna, I think is what's going to go on. That's a joke, I guess, not very funny. So we're moving on. Okay. So challenges with the Lambda and Kafka architectures. I don't know if you guys are familiar, if you come from a streaming background, you have the Kafka layer, you have the Spark layer, which is the speed layer. You're going into an offline like batch, so we're going into HBase as a storage, and then we also have other types of caching and aggregation layers. And so what happens is you're bifurcating your data stream. So you have one on the left, which is going fast, and I can serve real time. And then I need to, because I can't keep it all in memory, or I can't serve it fast enough, or I can't do my other use cases, I have to have it to the side. So what happens is it's essentially 2 streams, and then what happens is your data can start bifurcating and get different results over time. You have to go in, you have to go ahead and analyze these and get going. I want to show, that's the problem mean with the other blah. That's the main problem we have when we're doing the Kafka architecture. When we actually take a look at Performance BI here, we're not going to let this go because it's going to take 5 minutes. But when we're using GPUs to accelerate the fast OLAP side of things, you can see that as soon as I hit the down key, you know, we're there within 0.5 seconds, you know, or less than half a second or 2/3 of a second. And it's going to take several minutes to go ahead when we do the performance. The same thing is true when we're doing fast BI with some aggregations, with subquery, joining tables as well. You know, the Connecticut is going to come back at human speed at 2.5 seconds or a little bit beneath that, but the leading enterprise database is going to take 44 seconds. And so if I have come back from an analytics background, when you're doing these type of queries and you type it in and you're like, shit, I did it wrong the first time, I got to type it in and do another aggregation. So about 3 hours later, you actually get your query, because it takes 45 seconds of time. You actually can get it back and you can go through your different changes as you go through. So let's look at real-time advanced analytics, a speed layer, and this is going to be true for Hadoop or for your enterprise data warehouse, where we essentially, you go ahead and you run the data through the left side, which you have your source data, which is going to be either Kafka, Amazon Kinesis, MQ, ActiveMQ, any of those. It's going to be very similar. You can either go directly from there into Connecticut, or if you're going to, you can choose to run that through Spark Streaming to feed into Connecticut as well. And in Connecticut, in this case, you can say any GPU accelerated system that you want to go ahead and do your real-time analytics on. And you can also feed into and out of Oracle. And this is what I think a lot of people are more familiar with, the speed layer for Hadoop, where if you've been doing Hadoop, which I've been doing for about 7 years, you realize that when you start to design the system, it's great for batch, but the real-time aspect isn't there. And so those of us that have been doing real-time streaming analytics, we realize if we can do the batch fast enough, essentially, or we can do the streaming side fast enough, you can actually replace the batch side. And so what you can do here is you can also stream through your analytics speed layer, which we use GPU acceleration, which I'll go through some use cases and some slides to show you some pretty visuals in a minute. To actually show it in use, you can actually send it directly to your analysts and users. So this is what it's going to simplify. You're going to go from Kafka or whatever source you have. You can go Spark Streaming, and in this case, we're just using Spark to fetch from Kafka and push it directly to the GPU accelerated database. In this case, it's Connecticut, and then to the end user. And so we're just using Spark as a pass-through layer. It's just fetching from Kafka and streaming in via REST API. And this is the same thing we can go through. I'm going to go ahead and walk you through real quick. Of course, now I got to use my, now I got to swap from Windows land to, it's going to take me a second to think Windows land, sorry, from a Mac. There we go. And so this one here, we talked about GIS accelerated different use cases. This is the, I'm going to walk through a couple. This is the Twitter feed. This is the 1% Twitter feed. So we have a subset. And let me expand real quick here. Sorry, give me a second here. Let me see if I can, let me try to get this onto the whole screen. Does that show up for everybody? You can kind of see the screen here. Okay, cool. So what we're showing here is we're actually starting to stream in. This is actually a live feed. We're using the Twitter 1% feed. So we're not getting all of the data, we're just getting a subset here. And you can see it coming in, the new tweets. It's starting to come in. We're going to go ahead and look at some data. And as Chris said, we can do a bounding box. We can look up other things. Just because we're going to be a little bit here, I'm going to go do a search. This one's fun. I'm going to go look up people who've changed the tire in the rain, because I'm sure we're all super happy when we change the tire in the rain and we're tweeting about it. And if we look down below, we have some sentiment and emoji analysis. It's basically, is there a smiley? We did the in-database thing. We're looking at smiley faces and sad faces and going, are they angry or are they happy? So I'm just going to go look at people who are changing the tire in the rain. And I'm going to do a little text search here, and hopefully, since this is live, I get my syntax right. I'm going to say tire and rain. I'm just going to do it real quick, do a quick search here. And it comes back with 16. I must have clicked on something. I usually have a few hundred of these that show up. So tire and rain, I'm going to reset it. My screen's a little off. So I'm going to say, I'm going to look for anybody who's done tire and rain. All right, and I'm going to go ahead and say, I want those to be within about 5 words of each other so that I can say, I'm changing the tire in the rain. I'm just not getting somebody who's talking about some music DJ thing that I'm not familiar with. I'm going to go ahead and make it prettier colors because I don't like that color. I'll zoom in, and so let's go see. Now, I have not pre-selected any of these, so this is live Twitter data, so you guys know what that means. There's going to be a lot of pissed off people. So this person here saw a lady changing her flash tire in the rain. I stopped and thought about helping her. Good deed. So he actually didn't stop, which I think that's about the best one I could have clicked on. Good for that person. So you can go through, and this is used for a real use case. This is sentiment analysis. So if I'm going in and I wanted to look up United flights, this is a 1% feed, so we can't really look at people looking at United flights. If you want to go ahead and look, I'm not going to click through for obvious reasons, but let's go see how people are happy about our current president. We click on Trump, and let's see if we get surprisingly about 11,000, if you can see that, happy people to about 1,000 not so happy people, 10 to 1. So we're getting people that are actually 10 to 1 happy. And if I wanted to go ahead and say, how do people in Europe feel? I can, I'm just going to do a really big chunk of Europe there, and I can, you can drill through and go click on as well. And so something a little bit different to go through. Let's go a little bit more advanced analytics. So this is stock pricing for those that come from a financial background. This is more my sweet spot than GIS. And so this is looking at value at risk. So basically, if I'm going to go buy a bunch of stocks and I put $100 in Apple and I go simulate it 50,000 times, over what period of time, what's my expected loss or expected gain over that? So if I put $100 in, I could lose $12. And so my expected loss is $12. And then at the one, we could do the fancy finance thing and say peak under the curve. But 1% of the time, the worst case is how much would I lose, as you could look at that. And so what I'm going to do is I'm going to run something called the value at risk calculation, which usually takes, if you're running this in a typical database, when we're doing this, and I've done this at a few other places, it takes several minutes against a few billion different records. But this is like, I think, into the few million. So we take a look back and look at my value at risk, which is pretty cool. I can say NVIDIA is 7.7%. And if you look at these, they go over through time. So if I want to take a drill through and I want to say, in reality, I want to drill through and look at only diversified banks. And you can drill through. It's actually looking at the raw data. It's accumulating as fast as I want. I can go ahead and click Run Procedure. And it's going to go do my VAR for that subset of my portfolio. So for all the finance geeks, that's pretty cool. For everybody else, it's kind of like, I like Twitter stuff because it's more exciting. So let's go one more real quick one. So we're cutting through time. This is, I think a lot of people are familiar with the different taxi data sets as well. And so it's a very similar thing where you're maxing GIS, and you can take a look at, how much revenue do you have for different types of people. So I can say, for people who paid with credit card, and this is all accumulating on the fly. And I can say, how many of those, if I want to drill through and I want to say credit card with 6 passengers, I can filter through and just look at that subset. And you notice there's a huge density in this part of Manhattan where there's more people getting picked up. If you zoom in and out as well, and I zoomed in, made a little bit more time, you could see that the airports also, which kind of makes sense, right? Like you're getting picked up and around the bars, and if I went in and we zoomed in, we could look at the different bars and other things in that area. So we are starting to get Alt-Tab. Third time I'll do Alt-Tab. There we go. And I'll go through. So Chris, do you want to pick up? Because we started a little late. Let's do a couple of the use cases that open for questions. We did INSCOM. Let's do logistics. You want to go with it?
Yeah. So the U.S. Postal Service use case, we mentioned this in the beginning, but this is really cool. This is representative of the world's largest mobilized fleet. And we had went in there and we took if you picture the technology that you had just saw, what you were actually looking at there was a native visualization engine called Reveal, which is part of our database. It's by no means a replication for BI tools. It actually integrates very easily into them. But what we had done was we worked with the US Postal Service in order to optimize the routes that a lot of the couriers were driving. So, you picture the scenario, you are the world's largest mobilized fleet, and you are also under constant pressure because as online shopping becomes more readily available to everybody, people are much rather taking a route where they can just click a box, pay a couple more dollars, and then actually see where their package is in real time. So upon working with the US Postal Service, we were able to cut down the service level agreement, meaning that we were able to have mail delivered to the 256 million households that they serve in a much quicker amount of time. But that's only like a really small sliver of this use case. The US Postal Service, by back-ending their mobilized fleet with Connecticut, is now driving 70 million less miles per year across the 256 million households that they're serving, meaning that they're consuming under $7 million a gallon of fuel less. So, you're getting green footprint awards from the EPA for this type of thing. You're cutting down operational expenses dramatically. But one of the coolest things about this is, and I'm sure people in this room have seen this before, do you ever order something from UPS or Federal Express, and instead of it being all the way delivered to your house, you're seeing that it's now dropped off at the post office? So really the rationale behind this is the post office has a ton more little regional offices scattered all over the country. Like your UPSs and your FedEx, they have their regional hubs, but they're not in every community like the US Postal Service is. So rather than being directly competitive to the UPS and the Federal Expresses of the world, because we enabled this tracking capability for this use case, they're now in partnership with these organizations, and it actually opens up a revenue sharing model. So by optimizing the route that these millions of mail trucks are driving per year, what we did was we opened up a new revenue stream, we dropped down operational expenses, and then we also cut the time that it takes to actually deliver the mail to the household. So all this was capable of being done by basically utilizing the GPU to handle streaming fast analytics in the sense that Woody was just walking through with the demos today.
Cool. I think we're so if you have any other questions, we're glad to take those. We have about 2 minutes left. If you want to do a deep dive in the tech or have other questions on this line, you can come see us at booth 431. We actually have really cool t-shirts as well. If that's the one thing you get out of this talk, you can definitely get a really cool GPU-enabled t-shirt. Do we have any questions or follow-up?
Let's thank the speaker.